Hi guys, this is trigonometric equations part 4. So they're dealing with equations with two trig functions in them. So it is challenging to solve equations with two trig functions involved. So the ones that we've done previously have only had one sort of trig function in them. But what if I've got an equation like this where it's sine of x plus root 3 times cos of x equals 0. So this becomes significantly harder because we're dealing with sine and cos in the one equation. So the strategy is to change the equation to only have one trig function. We've got to somehow work with these sines and coses, for example, to become to change them up so that only one trig function is seen. Once you've only got one, you can isolate it and use the basic methods to solve it. Okay, so for example, let's do this one here. So sine x plus root 3 cos x equals 0. Okay, and notice they've given us a domain for x, which is really important. X is between 0 and 360. Okay, so let's give this a shot. So the way to do this one, when you're dealing with a sine and a cos, a really helpful thing to do is to change your sine to tan. And the way to do that is to put sine over cos, and that becomes tan. So that's the way you can make a sine become a tan, by dividing everything by cos. Notice also that cos divided by cos will give you 1, and that will mean that there will be no longer any trig ratio here, and it'll leave you just a tan, which can be solved. So really important just to remember this sort of trick, to divide everything by cos, because that gets rid of that, and that becomes just tan, and you're left with one trig ratio. Okay, so sine over cos gives you that. Over here, the coses on top of each other, they will end up cancelling. And 0 divided by cos, or 0 divided by anything, is just 0. It doesn't change. So that's why, another thing, that is why 0 is really is a really good number to have on one side, because even though we're introducing a trig ratio over here, it won't stay. Like 0 divided by anything, it just stays 0. It doesn't become a trig ratio. Whereas say if that was a 1, that wouldn't be the case, because 1 divided by cos theta, that equals sec. So therefore you still would have two trig functions. But anyway, it converts to this function here, this equation here, and we can solve that for x. Okay, so let's use the basic methods for this sort of equation. We want to isolate our x. So first things first, you would minus the root 3. So you get tan of x equals negative root 3. Then you'd get x by itself, doing inverse tan. Notice that we're inversing tan of a negative root 3. So we want to change it to the positive version of root 3. And we get that the related angle is 60 degrees. We want our tan to be negative, because it's negative root 3 there. So therefore we want to work in the second and the fourth quadrant for tan, where it's negative, and we want to make a 60 degree angle. So there's our 60 degree angle in the second quadrant. What is that angle with the 0 degree line? It's going to be 120. So that's our first value for x. And in the fourth quadrant, and notice that our domain is 0 to 360, so it's only positive angles. So we're only going anti-clockwise. And in the fourth quadrant, when we make our 60 degree angle here, we've got to go all the way around, and that's going to be a 300 degree angle for that 60 degree angle. So we get 300. So these are our two values for x. Done. Okay, let's try another one. So solve 2 cot theta. So notice that's not a compound angle, it's just a normal angle. 2 cot theta equals cosec theta. So we've got two trig functions, which is a problem. We've got to change it up so there's only one. And we've got that theta is between minus 180 and positive 180. So we're going to be doing a bit of clockwise negative angle stuff and a bit of anti-clockwise stuff as well. So we got to think to ourselves, how do we make it so there's only one trig ratio? Well, a good practice is to change these things into sines and coses. So cot is the same as cos over sine. Notice the 2 stays on top. Cosec is 1 over sine. So you get this situation here. Now notice that you've got sine on the bottom for both. If we multiply both sides by sine, it'll cancel both of them out, and it will leave you with just the top, which is just one trig function, which is perfect. So those signs cancel, we're left with 2 cos theta equals 1. Okay, now we can solve this one because there's only one trig function. Perfect. First up, we've got to figure out what theta is. So we're going to divide by 2 first. So cos theta is equal to half. Take the inverse of cos, and we get that theta is equal to 60 degrees for our related angle. Okay, so we've got to make 60-degree angles, and we need our cos to be positive. So that's going to be in the first and the fourth quadrant. And notice that that theta is going from negative 180 to positive 180. So for the negative angles, all this stuff under here is going to be negative, and all the stuff on top is going to be positive. Okay, so how do we make these 60-degree angles in the first and the fourth? Let's do the first quadrant first. So that's that 60-degree angle. It's just going to be 60 degrees as the first value. For the second 60-degree angle underneath here, that's going to be part of our negative range because we're going to negative 180. So that's going to be the angle negative 60 degrees. Okay, and there's our solutions. There's our values for theta. We're just trying to figure out what theta was. So 2 values needed, done. Hope this helps you with some of these sorts of questions. See ya.